Well, let's see the imbalanced dataset problem and let's code it. And in slice we talk about when we face this problem, and in convolutional neural network, in neural networks, and in machine learning algorithms, you can see the problem of imbalanced dataset. So this is not the problem of only neural networks or only machine learning, and also I don't cover this problem with the perspective of convolutional neural networks for this lecture, because we will go the application of imbalanced dataset solutions in convolutional neural networks. However, I will show how to face with this problem in machine learning algorithm. So let's import our data and let's import our libraries. To do not face with problem, I am just copying them, also I don't want to steal your time. Well, from Scikit datasets we import make classification to import the data, to create fake data, and also we imported neural network from scikit-learn, and also to plot our data we have matplotlib and its pyplot. And then let's create a fake data, and let's say that we have x1 and y1, and let's make classification. Let's say that our number of sample is 1000, and we have number of classes of 3. We have 3 classes, and then let's say there are 2 features, and 2 of them is important. 2 of our class is informative and important, and also we have no redundant features. All the features are important for our case, and also we have number of clusters per class is 1, and let's say that shuffle the data, and also this is the important part. We have the weights, like for the first class that we have 0.01, and also for the second class we have 0.01 weight again. It means that our only 1% of data is from the class 2 and also class 1, and we have 0.98. It means that 98% of class 3, 98% of our data is class 3, and let's say that we have the class separator is 0.6. We created the data, and let's scatter it, and x1, y1, it's not that easy, and to scatter it I don't want to lose the time, I will copy and paste it. Well, let's run it, and when we run it we see that there are few sample of 2 classes, and this is the one of the classes, and let's go back, and there are another sample in that color, and also lots of the classes are from these color. So let's run it again. I want to show some imbalanced dataset problem in a graph format, and when I run it again, you see there are always the cases that we have majority class and minority class in some areas. So these are the cases that you can face with imbalanced dataset problem. And now we will apply machine learning algorithm, and this will be neural networks. And before going into that, we will split our data into a training and validation. Let's say that we have training X data, and this is the first 700 of our X, and training Y is the first 700 of Y1, And for validation, we will have the first, the samples that are over 700, and let's say that we have created we now created our training data and validation data, and we have the neural network architecture. And now in multilayer perceptron we will have multilayer perceptron classifier, and this is our model. And in our model we will fit the training data, and to see the training accuracy and validation accuracy, let's say that we have accuracy during training. So you have validation data and training data, and you want to see the scores of it, or how well your machine learning architecture works on this data. And you see that when you run model.score in scikit-learn, in training data you have good accuracy. However, let's see how we will get in validation data. Let's correct it. Why? So now we are ready to go. So now you finished the training stage, and this is your data. And when you see the accuracies, you see that 99% of correction, and this is in training data. And you think that there are also the case of overfitting. There can be also a case of overfitting. However, in validation data also you have the 99% of accuracy. So you go to the application of your project, and you see that every sample or every input is classified in the majority class. So your machine learning algorithm always predicts the same class, and this is the majority class. And now you are curious about the problem, and you try to analyze the minority classes, and you test the minority classes, and you see how well your machine learning algorithm performs on the minority classes. So to test that, you will get these codes and copy and paste them. However, first of all, you think that in your data you have some classes some classes that is 1, and to do that you need some logic function like that. And after that your aim is how well your machine learning algorithm performs on the minority class, and you analyze the class 1 on the validation data, and you run it. After that you see your machine learning algorithm has no successful correct prediction in the class 0 or in the class 1. Sorry, the first class. In the first class you have no correct predictions, and you see that how it's happened, and you check for the other one, and let's do it like that. And again, for the cases that you have very good accuracy for training and validation, you have 0 correct predictions on minority class, and this class is the other class. And for the majority class, in your validation data you have a very good of accuracy and you can predict all of the data that is from majority class. And you see that, well, that's should be a problem that must have a name, and you search from Quora, from Stack Overflow, and you see that this is the problem of imbalanced data. And you want to, let's say that you want to analyze the same thing but in the training data, and to do that you again should have, let's do it like that. You want to see every element of correct predictions for the same data. Sorry, these should be 1, 1, 2, 2. And this is the validation part. This is the training part of your minority test. And let's not steal your time. Well, this is your test, and when you run it, you will see that in every case, in every case you have a good training accuracy, you have bad results in the minority classes, even in training data and also in validation data, but you always have nearly 100% of correct results in the majority class. So let's run it again in different architecture, and there are some cases that you don't affected by imbalanced data problem for only one class. This has an explanation, but my aim is now how to analyze the problem of imbalanced dataset, and this is the way to analyze the imbalanced dataset problem. So then we will talk about the solutions, but in convolutional neural networks and also in the code of us in Keras, the data generator, in the example of the case of transfer learning. In this example, we will also be talking about how to avoid imbalanced dataset problem, but to do that we will manipulate our dataset.